Alrighty, here we go, section 10.2. This is using combinations and the binomial theorem. First of all, let's take a stab at the warm-up, and then I'll talk about what a combination is and how it's different from a permutation. So pause the video, go through it real quick, and then just check your answers with what I have. Okay, this is what you should have gotten, hopefully. You could either do it on the calculator, or you could just know that 5 factorial is 5 times 4 times 3 times 2 times 1. Many of you can probably do that in your head. This is just 2 times 3 factorial, which is 12. 8 factorial divided by 5 factorial is actually the same as 8 permutate 3. Same thing. This one here is 7p5 is 2520. And then in how many ways can 6 people line up for a movie, for tickets? So the first person, there's 6 people to choose from, and then there's 5 to choose from. 4, 3, 2, and 1. Because order matters there. So that is just 6 factorial. All right, combinations is a little bit different than permutations because order is not important here. For example, if you're dealing a deck of cards into 5 card hands, that's sort of an example. It doesn't matter what order those cards are dealt. We're just seeing how many ways we can take 52 cards and deal hands of 5. And order doesn't matter. I guess that's an important thing to just keep remembering. In combinations, order doesn't matter. So key words that you look for to help you decide whether it's a combination is words like pairing, group, committee. When you see those kinds of words, you know that you're grouping and you're going to use combination. So let's practice it a little bit. Combinations, here's the general form for combinations. N choose R equals n factorial divided by n minus r factorial. Now that part here, that's the equation for permutations. The thing that's different here is you add in the denominator is multiplied by r factorial again. So let's just do a little practice with this. Parents have 10 books that they can read to their children this week. 5 of the books are nonfiction, and 5 of the books are fiction. If the order in which they are read is not important, order is not important, that tells me right there that's a combination. How many different sets of 4 books can they choose from? All right, before we even go here, I forgot to have you write something. I want you to write something up here, right by the notes. If you see the word and, events, when they're talking about certain events and they use the word and, you're going to end up multiplying combinations. If you see the word or, when they're talking about different events, you're going to end up adding. So write that down for yourself. Okay, so for this first one here, it says, if order in which they read the books is not important, how many different sets of 4 books can they choose? So they have 10 books altogether. We want to know how many groups of 4 we can choose. So order doesn't matter, so I'm going to do all my total 10 books, choose 4. Now remember, the first number is the N, the second number is the R. If I just kind of plug it into this equation right here, let's see what it looks like. I know you can put it on the calculator, but you got to know how to set it up with the equation as well. So in the numerator is your 10 factorial. That's n factorial. In the denominator, you do n minus r factorial, which would be 6 factorial, times r factorial, which is 4 factorial. So when you do this math, and you can throw that on the calculator, you'll end up getting 210 ways. And so that's how you do that. It's pretty easy. In B, it says how many groups of 4 books are all the books either nonfiction or, there's that word or, which I was just referring to up here, or fiction. So we have to do 2 different combinations here. Remember, there's 5 nonfiction and 5 fiction books. So for fiction, I'm going to write, I have 5 to choose 4 from of the fiction ones. And I'm going to add to that the nonfiction choices. So from the nonfiction I have 5 and I'm choosing 4. So now I'm going to find out how many ways that can happen. When you do this on the calculator, or you just kind of think about it plugged into here, it ends up being 5 choose 4 is 5. And then another 5 choose 4 is also 5. And when you add them together, you get 10. There's 10 different ways that groups of 4 books can be chosen. 10 different ways that can happen. So, turn the page, okay? Let's do some more. All right, so in the packets that I gave you of these notes, your pages are out of order. So if you go to the next page, this is the page we're working on right now. This is actually page 2. So sorry I put them out of order, but that is page 2. So, all right, for this one it says the student senate consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. So I'm going to take a second and just add those up because I have a feeling I might need the total later. I don't know, maybe not, but I'm going to write that down. Part A says how many different committees, there's that word committee, which is going to make me realize I'm going to use combinations, of exactly 2 seniors and 2 juniors can be chosen. So when I see the word and, I know that I'm going to be multiplying my combinations together because I'm talking about seniors and juniors here. So let's go up here and do the seniors first. I have 6 seniors, I need to choose 2. I'm going to multiply that by the juniors option. I have 5 juniors and I'm going to choose 2 of them. Again, you can just do that on the calculator, or you could plug it into the formula. You'll get plenty of practice with that. 6 choose 2 turns out to be 15. 5 choose 2 turns out to be 10. And when I multiply that together, I get 150 ways that this can be happen. For that committee, there's 150 different ways that committee can be chosen with 2 seniors and 2 juniors. The next thing says how many different committees of at most, so here's an important word right here, at most 4 students can be chosen. That means I'm going to figure out the ways that I can choose a committee of 4 out of 18, but then I also might have a committee of 3 only out of 18, so I'm going to have to go down the line. So what this says, at most 4 students, that means 4 or less. Committees of 4 or less. And when I see that word or, I know I've got to add all the different possible combinations together. So let's start with a 4-person committee. So what I have here then is I have 18 total to choose from. So 18 choose 4. So I'm going to add to that a committee of a 3-person committee. So it's 18 choose 3. Then I'm going to add to it the possibility of a 2-person committee. So I have 18 people choose 2. And the last one could be a committee of 1. You never know. 18 people choose 1. So you just go on your calculator and you do all of those and you add them all up, and there's 4,047 ways that you could choose committees of at most 4 students, or 4 or less. That's a lot of ways. Okay, this one says you're going to toss 10 different coins. How many different ways will at least 4 of the coins show heads? So here we're at least 4. That means 4 or more. So again, you're going to use adding all the possibilities up. So if you toss 10 different coins, how many different ways will at least 4 of the coins show heads? So I've got to start with the 10 tosses. And I'm going to start with the smallest number this time. Let's 10 choose 4. Okay, so next time I'm going to say, all right, in 10 tosses, how about 10 choose 5? This time 5 of them will be heads. And then there's also the possibility that 6 of them will be heads out of the 10 tosses. And you see where I'm going with this. 10 choose 7 plus 10 choose 8 plus 10, choose 9. And then last but not least, the possibility that all of them will show heads, which is pretty unlikely. So you just do this big long summation, right, on your calculator, and it turns out there's 848 ways that at least 4 of the coins will show heads. Alrighty, Pascal's triangle. You may have heard of Pascal's triangle before or not, but we're going to talk about it a little bit. It has a lot to do with combinations. The first and last numbers of each row are 1 right here in Pascal's triangle. Every other number other than 1 is the sum of the closest 2 numbers in the row directly above it. So let's just look at this right here, Pascal's triangles as numbers. You notice that on the outside they're all 1s. And then when you get here, these 2 numbers added together are 2. If you add these 2 together, you get 3. And those 2 together, you get 3. And you can see it kind of goes that way all the way down. So it's really easy to write down Pascal's triangle just based on that pattern. There's all sorts of other pretty cool things that you can do with Pascal's triangle, but we're going to talk about how you can use it with combinations. So kind of take a look here. We're going to go row by row. The first row is called the 0 row because it's 0, choose 0. And there's only one way that can happen. The first row, it says here 1, choose 0, and 1, choose 1. And there's a one way that both of those can happen. This one goes with that number, that one goes with that number. Now let's go down here to say the fourth row. Let's say I go in one spot and I have 4, choose 1, and I go to the same spot here on the triangle. There's 4 ways that that can happen. 4, choose 2, there's 6 ways that can happen. Now don't get that's kind of a coincidence that you add them together and they're the same number. Because when you go down here to the fifth row, look at the third spot in is 5, choose 2, and there's 10 ways that can happen. And then 5, choose 3 is also 10 ways because this triangle is symmetrical. So we're going to add on to this because we're going to need a couple of more rows here. So 6th row, n equals 6. The outside number is always 1, and then I just can go across by adding the 2 above. That's 6, that's 15, that's 20, that's 15, that's 6, and the outside's always 1. Then I'm going to do the 7th row. So the outside's always 1, and then you just go across, add 1 and 6, 6 and 15, add the 15 and 20, and then it's just symmetrical as you keep going. 15 and 20 is 35 again, 21, 7, and 1. And that's the 7th row. All right, so we're going to use this. We're going to practice a little bit. From a collection of 7 baseball caps, you want to trade 3 of them. Use Pascal's triangle to find the number of combinations of 3 caps that can be traded. So we have 7 caps. We want to choose 3. So it's tempting to go to the 7th row and say, okay, I'm going to go 3 in, and my answer is 21. But you have to remember that the first spot in the triangle represents n choose 0. So here's 7 choose 0. That's not what we want. We want 7 choose 3. So then the next spot is 7 choose 1. This would be 7 choose 2, and then 7 choose 3 is here. So our answer is 35. So that's how you can use Pascal's triangles to come up with the number. Yes, I know you can use your calculator, but guess what? And the next thing we're going to do, you have to use this to help you out. And it makes a huge difference to be able to use this to figure out the number of combinations based on whatever you're choosing. All right? But this one, pretty easy. Just count in to the right spot, and you've got your answer. Okay, let's go to page 3. Okay, page 3. It's a process used to expand polynomials. So like, let's say you have x plus y to the 11th. Well, that would be a huge pain in the butt to do by hand. So this is a special little process that you can use to simplify it. And it really isn't too bad, to be honest with you. So I have steps here because I'm a step follower. The exponent tells you which row of Pascal's triangle to use as coefficients. So you write the first term from right to left, decreasing exponents. But first, let's just go step by step. So right here, we're going to expand x plus y to the 5th. So I'm going to go to Pascal's triangle, 5th row, right here. and I'm going to look at these numbers 1, 5, 10, 10, 5, 1, and I'm going to write them down right here, but leave some room underneath and kind of spread them out. That's the first thing that you do. And you're going to make columns. Make some columns, not too long. Leave a space for a row underneath here, which I didn't do for this one, but we'll just cross that off. So that's the first thing you do. It tells you which row of Pascal's triangles to use as coefficients. The second thing you do is you write the first term from left to right with decreasing exponents. So here, this is x, and you know you're going to have x to the fifth. So that's going to be your first term, x to the fifth, and then you go down, x to the fourth, x cubed, x squared, x to the 1, and you will have an empty spot. Definitely. Then it says, write the second term from right to left with decreasing exponents. So I'm going to start here with y to the fifth, y to the fourth, y to the third, y squared, and y to the first. And you will have an empty spot here as well. Now you're ready to actually come up with the final answer. That's your setup. Okay? So simplify each column. What you do is you take this number and you multiply it by what's here, and you just write what that is right underneath, x to the fifth. Okay? Take this number, multiply it by this term and by this term, and you write it right down here, 5x to the fourth y. Same thing here. This is going to be 10 times this, and it's just 10x cubed y squared. Same thing here, 10x squared y cubed. Notice the difference in the exponents here. And then here is 5xy to the fourth, and then multiply down and you have y to the fifth. And then the last step that you do is fill in the signs. If you have a plus here, then it's going to be a plus between every single term. Plus, 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 and plus. And that is your final answer right there. That would be that multiplied out. And it's a lot easier to do it this way than to try and do it by foiling. Okay, let's do another one, just because they're so much fun. Okay, so right here we have 3x minus 2 to the fourth. So remember, the exponent tells you which row of Pascal's triangle to use as coefficients. Now you may notice on the back of your packet, I put an extra copy of Pascal's triangle. So you might want to number the rows just so you don't get messed up. Row 0, 1, 2, 3, 4. Now this right here, the exponent is 4, so I've got to write down 1, 4, 6, 4, 1. That's going to be the first step with a space in between. And that's the beginning. The next thing I do is I write the first term with decreasing exponents across. So it's going to be 3x to the fourth in parentheses. You've got to put this in parentheses though, and I'll show you why. Then it's going to be 3x to the third, 3x squared, 3x to the first, and then you leave this one blank. So important that you put the 3x in parentheses, otherwise you will not get the right answer. And that's a common mistake. Students forget to do that. Then you write the second term down and you go from right to left. So you don't have to worry about the minus right now, and I'll show you why. You just do 2 to the fourth, 2 to the third, 2 squared, and 2 to the first, and you will have an empty spot here. So I'm just going to draw little columns just to keep myself straight. And I'm going to draw a line right there. And now I'm ready to start simplifying. So column by column, it gets a little bit trickier when you have some numbers here. So we're going to do 1 times this. But remember, when you have an exponent outside, it's the fourth of both of those things in there. So you may not remember, but 3 to the fourth is 81. So I have 81 times 1. So I have 81x to the fourth for my first term. Here I have 3 to the third, which is 27, times 4 is 108, so I have 4 times 27, which is 108, times 2, which is 216, and I have x to the third. So that's that term there. Here, I have 6 times 3 squared, which is 9, that's 54, times 4. That's also 216, and I have x squared for that term. Here I have 4 times 3 to the 1, which is just 12, times 2 cubed, which is 8, so I have 12 times 8, which is 96, x to the 1, which is just x. And then here I have 2 to the 4th, which is 16. Just to be less confusing, I'm going to make this also pink. Okay? So now we have all of our terms. Now we go back up here and it says if it's a plus in between, you fill plus in all the way across, but if it's a minus in between, you alternate minus, plus, minus. So this is going to be minus, this is going to be plus, this is going to be minus, and that's going to be plus. And then you have your answer right there. That's that times itself 4 times. Pretty nifty. It takes a little practice. Okay? All right. This is the last thing you're going to have to do, but I want you to cross this stuff off. You don't need all that. That's just too complicated. Okay? So it says, find the coefficient of x cubed y to the 4th in the expansion of 2x minus y to the 7th. So we want to know where you have these coefficients on the x and the y if you were to FOIL this out or use the binomial. And we don't have to do the whole binomial to do it. There's just a quick trick. So the first thing I want you to do, so you know they're asking you for where x is cubed, so you're going to take this first term and you're going to write 2x cubed. And you might notice up here that you notice that the exponents have to add up to the 7 here. So that means this is going to be y to the 4th, so I'm going to go negative y to the 4th, just like that. So I put the exponent for the original thing right here on the 2x and the 4 on that. And then I have to figure out what goes in front of here. And all you do, and this is just kind of a remember it, is if you look up here, the coefficient is going to be n, choose 0, and 0 is whatever is on the second term here, the second exponent. So if I write this here, I'm going to have 7, choose 4. If I simplify this, I'm going to find out the coefficient here. So let's simplify this. So what's 7 choose 4? 7 choose 4. I don't know. You can go to your calculator, or you could go to Pascal's triangle, which we wrote right here. If I go one more, 7 choose 4 is 35. But I'm not done yet, and I'll show you why. I'm going to write this down here too. 7 choose 4 is 35. What would 2 to the 3rd be? I'm going to write 2 to the 3rd. I'm going to write x cubed. I'm going to write this as negative 1 to the 4th and y to the 4th. And then I've got to multiply everything that's a number together to get my coefficient. So 2 cubed is 8, so I have 35 times 8. This is just going to be 1. And then I have x cubed y to the 4th. 35 times 8 times 1 is 280. X cubed y to the 4th.